my goodness, I think I broke my chair.
Oh no!
No, our chair.
I don't know if you can look at.
Ladies and gentlemen, welcome back to the shop.
Here it is. Our Mark II hydrogen generator. This time we're building a dry cell. I've done my research and I have all of the materials here. We got our electrode plates, neutral plates, gaskets, front and back plates with some metal reinforcements. So I had all this ready to go about a month and a half ago, and I had a different, well, come on. I was using a different material for the gaskets. As you can see, this is a proper neoprene rubber. I got a whole roll of it. I'll show you guys that in a second. But before this, I was using closed cell neoprene foam, which I thought, because it's closed cell, would be waterproof, but it wasn't. So I had this whole thing put together. I tried putting the electrolyte in and it leaked. So I had to order a whole new roll, and then it wasn't enough, so I had to order more, and that's why there was so many delays and it took so long to make this thing. Let me get you guys set up and then we can talk about how this thing is gonna work. So let's dive right into this build, and first things first, I want to kind of explain what I've come up with. And so let me draw out this cell real quick. So this is a very, very condensed and simplified version of it, but this is basically exactly how it works. So these big lines are our anodes and cathodes. The little lines are the neutral plates. The empty spaces are the gaskets, but we don't really need to show that in order to show how it works. And these big tubes here are the in and outs. So this top one is the out, where our gas comes out of, which is oxygen and hydrogen. And the bottom one is the input, which we pump water into. So our cell works by having electricity run through the cell, splitting the water into hydrogen and oxygen. Now, the electricity wants to jump from the negative plate to the positive plate, right? But because we have our neutral plates in between, the neutral plates divide the original voltage into however many you're dividing by. So we have 5 neutral plates in between, which means if we have 12 volts, we divide it by 5. That is a 5, in fact. And that'll give us 2.4 volts, right? So each of these spaces here, right, in between, has, if you measure from this plate to this plate, the gap in between here is going to measure 2.4 volts. But in total, if you measure from the big plate to the big plate, it'll measure 12 volts, right? And the same is true for the other ones here. So we have our current jumping from the big plate into the little plate and on. And each time it does that, it splits water into hydrogen and oxygen. Now, you might be wondering, how does this work if these plates here don't have, aren't hooked up, right? If they aren't hooked up to the electricity. And that is because if we just take this one chunk here, this is essentially a circuit. We have our input, or our negative here, and so each one of these plates is hooked up in series because they're all connected by water. And so each of these middle neutral plates starts acting like an anode and a cathode, because on whatever side it's facing, it would be, man, it's been a while. Cathode is positive. So if we're going from the negative to the positive, then on the one side here, it acts as an anode, and on the other side, no, it acts as a cathode, and then on the other side, it acts as an anode because it jumps from here to here, right? At least that's how I understand it. If I'm wrong, please correct me. This seems to be the most common way to do hydrogen generators, at least from what I've seen, and especially with the 5 plates in between, because it reduces this 12 volts into 2.4, which is ideal for making the plates themselves last longer. Because if you use higher current, it becomes more corrosive, and then, you know, you got to start replacing plates more often. But that is my plan. I hope I explained that properly. If you have any questions, please let me know in the comments. I'll do my best to explain it. But let's get back into the materials and how I put it all together. So here we have the primary tools I use to cut my gaskets and my plates. And, well, I should add this in there. When I was building this thing, I tried to make the process as simple as possible and as cheap as possible. So what I did was, for the gaskets, I ordered this roll of 1/8 inch neoprene rubber. Then, out of sheet metal, I made a template that lets me cut it out exactly and consistently. Right, so I put it on, take the box cutter, cut it out, and that leaves me with these perfectly matching gaskets. And then, well, before I did all this, I ordered stainless steel sheets. They were 12 by 12 inches, which means that I could cut out 4 per plate, or 4 per sheet. Our sheet came like this. I marked out my lines and then took offset tin snips and cut them out, right? Followed my lines, and then using my, where did it go? My gasket template, I marked off where I need to cut the corners off, as you can see here. And then I just used the snips to cut the corners off and, sand the edges a little bit so they're not as sharp. And then I put the whole stack together and then drilled my in and out holes for where the gas and the water comes in and leaves into all of them roughly in the same spot. The holes aren't exact. As you can see through it, but there's a little bit of overlap. Now, I did all this with the drill press, and so there was obviously a little bit of a margin for error there. But it's not a big deal because there's space in between it all, and we're dealing with water anyway, so it'll find its way. So that was the internals. Now here we have our externals. This was a more recent addition. I did a test fit with just our base plates, which these are just a cutting board I got from Walmart. These were 2 cutting boards here. So I just took them, cut them into my 6-inch square pieces. Actually, they're slightly larger. I think they're 7-inch because I needed that 1/2 inch to add holes for the bolts. So essentially, these guys just sandwich the whole bundle together, and that's what holds it together. These guys fit together just like so. And these metal supports here are meant to just give it more tension so that I can screw the whole thing down without the plastic bending. Because that's what was happening when I tried it with just the plastic. The plastic on the corners and even in between the bolts here would bow outwards. And I feel like in the long term that's not really going to work out. So I made these metal support frames here. So I think that covers most of it. These guys are just hose barbs that I epoxied into place, screwed all the way through and sealed properly so that they don't leak. I think we can start assembling the cell now, actually. Oh. I think it's probably important to point out that my electrode plates are different from the neutral plates. So this is a neutral plate, and as you can see, both of the corners are cut off. And this is an electrode plate, and it still has its one corner. Right, so this way I can run a bolt from the positive to the other positive, and on the other side I can have a bolt for the negatives, as you can see here, and that'll let me wire them up that way, which should simplify that process. Although I'm not fully sure that I'm going to use a bolt yet. I'll figure something out. We'll see. But yeah, let's go put this thing together. So here's our cell. It's basically ready to go. I have 4 bolts in just for now. Before I close it up completely, I'm gonna go and check that everything's lined up properly. I have some holes here that these bolts in the corners need to sit in. on both sides. And so before I tighten everything up, I'm going to make sure that sits flush and that the bolt heads sit inside that hole so it's not going to bend the plates. And then we'll go and take this thing and mount it into a little carry handle or a carry box thingy so that we can take it from place to place wherever we need to do some torch work or something. So yeah, I'll be back in a second. Here is our cell all bolted together. I also went ahead and connected our 2 electrode plates on both sides here. And then all we have to do is connect our lead to either side. And then the way I was planning, so as I said earlier, I have been working on this thing for something like 2 months. And I had this whole thing mounted up with the power supply from the old hydrogen generator. And I built it so that this thing fits right in there, just like so. For now, it's going to be a little wobbly until we have everything put together. But on the front here, there is this little mounting band thingy and a little shelf, and that is for our reservoir. So that'll sit up here, and then as you can see, the hoses are going to connect to the cell like so, and then obviously it'll be tucked away so it's nice and neat. Let's go ahead and screw that on. I think what we'll do is we'll fill the system with just tap water for now, make sure that it's not leaking, because last time I didn't do that and just went ahead with the electrolyte, which is a somewhat caustic solution, and that was not fun to have to clean up. So this time we're going to do it properly. We're going to fill our reservoir and our cell, and we're just going to let it sit for a little bit and see if we have any leaks. And then once I'm sure that we're all good to go, we can go ahead and mix up our electrolyte and put it in there. Alrighty, our testing is done. It looks like there's no leaking. That little puddle there is from when I drained it, because I unhooked all the hoses so that we can work on the electricals. If it works half as well as it looks, I'll be happy. I think that makes sense. I have gone ahead and measured out 2 liters of water here, distilled water. I have my scale here with a little container that'll let me pour it into the jug and zero it. So I'm gonna go for a 20% concentration solution. And so what I will be doing is, since we have 2 liters, I'm gonna measure out 400 grams. You know, that adds up to our 20%. Oh my goodness, this is a lot. That's close enough for me. So now we can go ahead and add the potassium hydroxide to our jug. And for that, I'm going to make a little funnel so that it doesn't spill everywhere. See if you can see that. Can you see that, like, weird separation of the layers there? There it is. That's so weird. It's ready to go now, pretty much. So all we need to do is pour our solution in. Fingers crossed. There we go. You know what, that should be good enough for now. I'm not gonna fill it all the way. So we got our power switches on the back here. If you're interested in how I made this, I showed it in a previous video. And we have everything hooked up, our bubblers hooked up. All that's left is to turn it on and see what happens. All right, I'm gonna put on some glasses. So before we get into this, I just want to say that we blew right past 50 subscribers and we're just shy of 60 at this point. And I just want to say thank you guys so much. This crazy support for like these ridiculous projects that I'm working on out here. It means the world to me that you guys are actually supporting and commenting and enjoying the videos. Like it really means a lot to me. So thank you, and I'm looking forward to hitting 100 and however many more in the future. But yeah, let's get right back to it and actually see if this thing works. I'm stoked. Ladies and gentlemen, engaging in 3, 2, 1. Okay. I don't see anything. Oh, not this again! Oh. Oh. Ten? Still 10? Okay. Holy shit. Dude, no way. Dude! What? That's mega! What? There's no way it actually worked. Like there's no way. What? No. You're kidding me. We're running on this one side and on the other. This is ridiculous. Okay, so now that we have this crazy success, let me show you what I'm planning for safety measures. So we have our first reservoir slash bubbler. Now I don't want to directly hook up to this one because in case there's a flashback, you know, that's the reservoir, and if that gets damaged then we have a bunch of caustic solution spilling everywhere and that's not good. So what I'm going to do is I'm going to have this as a standalone kind of thingy going into a second bubbler, which will also help to dry out the gas, because as it comes out there's a lot of water vapor in it, and so it's better to run it through a second bubbler to cool it down. And on top of this we're going to add some plastic foil.
Hey guys, it's Future Neil here, traveling back in time through the power of editing, and the thing I'm talking about right here is what I like to call a pressure membrane. And so if the pressure inside the bubbler increases too much, like if there is a flashback and the thing explodes, instead of the jar exploding, the pressure is able to escape through the membrane because the membrane just pops.
Okay, so I just drilled out the top of this lid with a hole saw. As you can see, the top of the lid is still on here. If you just watch the top of the lid here, as soon as I plug the hole, it inflates. That is exactly how we want it. So I have a little bit of a system jerry-rigged up here. I've got a tube connected to the main bubbler. Runs into our little bubbler. It's just holes drilled straight in. This thing is leaky as heck, but I'm freezing to death in here. So I just want to test this to see if I can actually get a little bit of a flame on the torch, which we've got hooked up here. You see it goes straight into here. I wouldn't be surprised if this doesn't really work, because I felt earlier there's some leakage here. This isn't a tight seal, so we're losing pressure here. Obviously we're losing pressure here with this like crappy rubber band, and the seals here, it's leaking right where the thing connects to the bubbler. So I wouldn't expect this to give us too much of a result, but
we're gonna test it anyways. I don't know if you can see, but there's a little bit of a flame that comes, but the pressure doesn't seem to be enough. So it seems like this build has been a success, and after 2 months of work, I'm pretty satisfied, pretty happy with this outcome. I was expecting that the power supply wasn't going to cut it, and that I would have to source one from somewhere else. But I mean, it worked, so I'm happy about it. I hope you guys enjoyed this video, and in the next one, I'll go through stuff like the torch and the bubbler, and we'll do some more experimenting with the actual torch itself. I hope you guys enjoyed. If you did, please like, comment, subscribe. You guys are awesome. All the support and the love, it's just, it hits me right in the feels. I hope you guys have a good one. I'll see you in the next one, and have a great day. Bye-bye.